Okay, hi everyone. Welcome to our third live online meeting for the Foundation Statistics course using R. Great to see a nice group of students here. We have about 24, so welcome. And as you know, all these sessions are recorded, so you can feel free to go back and study them. In addition, the solutions are provided, and by this time you should probably already know where you can find the solutions. I also have them at the end of this slide deck. So I'd like to just do a quick roll call. And again, I just do this to make sure that you're kind of here, present, and your audio is working. And so there's 32 people registered, but only about 24 online. So just want to, I'll call out your name and you just tell me that you're here. I always do get a report, so if you did come in late to another meeting, don't worry about it. I get a report of anybody who's attended, even if you came in late. But again, I like to just do this to make sure that everything's kind of working and everyone's kind of present. So I'm going to go ahead and unmute everyone, so make sure you go ahead and mute yourself. And I'm just going to go through the list. So we'll start with Mark Parsons.
Hello.
Hi, Mark. Great. Kai Wei. Kai Wei, I see that you're here. Are you?
Good evening, everyone.
Oh, okay. Thank you. Thank you. And for any reason people's mics aren't working, you just let me know that you're present in the chat. Okay. So next I have Charlie Liu. Charlie, are you here?
Yeah, I'm here.
Thank you. And I just like to remind everybody to have your microphone on and you're not speaking, please mute yourself. Hear that bad feedback? So a few of you have your mics on and should mute yourself. Okay, let's move on. Mitchell Farber. Are you here, Mitchell? I see you.
I am here.
Great, thanks, Mitchell. Welcome. Gary Wright. I don't see Gary. Okay, Barath, are you here? I don't see Barath either. Jimmy Zhang.
Hey, can you hear me?
Yeah, I can. Thanks, Jimmy.
Great.
Theophilus.
I'm here.
Great, I saw you. Emmanuel. Emmanuel, are you here? I don't see you. Okay. Amer. I don't see Amer. Nande. Nande's not here. Okay, Mark Shertman.
I'm here.
Thank you. Libin Chen. I see you, Libin.
I'm here.
Thank
I'm
you.
here.
I'm here. You know what's so nice about this is I'm really getting to learn your names. Okay. Keith Jackson. Keith Jackson. I don't see.
Yeah, this is Keith. Can you hear me?
Oh, yes, we can. Thanks, Keith.
Great, thanks.
Sure. Chris Steele.
Hey, I'm here.
Great. Brad O'Hara.
Hi, I'm here.
Great. Welcome, Brad. Donnie Shearman. Oh, I see your message. Thank you, Donnie. Leandro Pena.
Hi, this is Leandro. I'm here.
Thank you. Marcus Person.
Hello, yes, I'm here.
Thank you. Aman Karki. Aman Karki, are you here? Don't see you. Okay, Mike Berger.
Hello.
Hi, Mike. Jeff Bevan. Okay, no. Check real quick. No, Jeff. David Lucy.
I'm here.
Thank you. Craig Sarich.
I'm here.
Thank you. Albert Sy.
I'm here.
Thank you. Vinod. I don't see Vinod. Okay. Jennifer Link.
here.
Okay, welcome, Jennifer. Jesus Riviera. Jesus, I see you online. Let us know in the text chat if you're having trouble with your audio. Next, Timothy West.
Yes, hi, I'm here.
Thank you. Rafael Gonzalez.
Hi, Professor, I'm here.
Hi, thank you. And Ajay Medaya. I don't see you. Okay. Well, thanks, everyone. So as always, please let me know if you have questions in the text chat, or feel free to raise your hand or speak up. Great, thank you. I see Jerry and a few other people. Great. So today we have, I think, a pretty fun agenda. Want to just remind you of just a few things. So this is the third session. So if for whatever reason you missed online session 1 or 2, you can make it up by sending me an email acknowledging that you missed the session and completing the assigned exercises, which are always available online, and submitting those. So that's a lot more work than we ask the people that actually attend the session. But the idea is that we want you to make it up and make sure that you've had some time to practice. And that's the whole thing. Practice makes perfect. So I hope people have been finding these sessions useful. Please, if there's any feedback that you have for me, I appreciate it. You can tell me privately or an email or even in the text chat here. Again, I really want to make sure that we take this time to make sure that you're building on your knowledge of R. The objectives and the overview for every session has been the same. It's not specific to, every session specific to a topic, but my goals for you are to help you move along in your knowledge of R. And as illustrated in our first online meeting, there's a real range of skills in the class, which is to be expected, and I know that because we've been teaching. This is like the sixth time I think I'm teaching this, and so to kind of get everybody on the same page. And then when we meet in person in May, we'll be doing a lot more in person, exploring more tools for, say, data visualization, for exploratory data analysis, and for working with data using some packages that you might not have used as much before, like ggplot or Tidy and dplyr. So those are all some good packages that we'll begin to learn, and we'll have some practice in class with some guided tutorials. So the in-class session will be very, very structured, but you will have a chance to practice even in the on-site session, because I believe that lecturing about programming is kind of probably the worst way to learn it. So want to make sure that you get some practice, and then you'll be able to go home and practice what we've done in class, and you'll have the solutions to practice as well. So you can do your own cause and effect and see what the answers should be and where you find yourself. Okay. So one of the topics in this course has to do with building graphs and basic graphs in R. And what are your thoughts on some of the graphs that you can create in R? Anybody have any feedback on them? I mean, some of the ones that I've asked you to make in session 5 are kind of hideous, right? They're kind of really basic out of the box. They might look like they came from the 1980s in terms of design. They are really, really basic. And so today we're gonna look at some of those basic histograms and box plots and things like that. Just want to check my audio. I'm just doing a test, make sure everybody can hear me. Okay, just want to do a test. Okay, just testing to see if you can hear me. I'm getting a message that something's wrong with the NYU network. So I'm hearing a few things, or not hearing. Maybe I'm not hearing anything at all. Okay, I just want another check. Can you hear me? Okay, so it's very interesting. When I teach from my apartment in New York City, I have perfect connection, and now I'm at NYU in my office, and I lose it. So NYU Stern used to have its own wireless network, which was, very, very reliable. And now we use the central NYU network. And for some reason it goes out. So I apologize. Sorry. Can somebody just just tell me where I left off? I was kind of on this screen. I guess I'll just start from here. Okay. At the very beginning. All right. Want to make sure you're learning. That's the point. And I asked some questions about, feedback and make sure that, these sessions have been useful to you. And now I know that I'm going to ask every 2 seconds a question just to make sure that I didn't lose my audio. Okay. When we meet in class, it's going to be very, very intense time, but you will be learning, various different packages, including Tidy and some packages for working with data. So this will be much more advanced. Right now, again, we're working on the fundamentals. I want to make sure that you can, use R as a basic level, and then we can build on that and expand more packages. And then you could also develop some patience, and some of these packages that are new and that are specifically designed for data science are still under development. So they're not perfect by any means. So we're working with ones that are, pretty well tested, and then we're going to build from there. Make sense? Somebody can give me a yes or a no. That would be awesome. Perfect. Also in class, we're going to be working on something called Shiny. Has anybody heard of Shiny? What is it? It's for apps, right? The Shining is what Mark is saying. Like the movie. No, I'm talking about an R package called Shiny. So here's my pitch to you. Okay, so I work with lots of capstone groups, and as part of this program that you can select a capstone advisor. And I wanted to just give you a little preview of one of the capstone projects that I just received the link to my team's app made in Shiny. And most of them that worked on this learned R as part, for the first time in this program. And so I'm just going to go ahead and go to my browser. And where it says disconnect from server. Just go here real quick. I'm disconnected because my network failed before. So you should be seeing, it might take a second or two. But what my capstone student did, so they're using this Shiny apps. They've built a prototype app using Shiny, which allows for interaction and interactive. You can build interactive websites. And so I'm really proud of my team. This is all placeholder text, if you can't tell. But their capstone isn't due yet, and they've already have a working app that supports their huge research paper and modeling. They created a predictive model to predict gentrification in certain areas of New York City, and they have a lot of parameters around that. But so they're looking to identify spots of gentrification. And why? Well, they're looking to do that because there's some research and evidence to suggest that areas that are gentrifying are or have signals of gentrification can be good investments for real estate investors or people just looking to buy a property. So this is an app that they created, and so you can kind of go ahead and search it, and I can say kind of search for say like an address like and I can compare this to a location. For instance, I could type 51 Kent Avenue, Brooklyn. And again, I've only tested this a few times, and I can compare the locations, and it will give me some comparison data. In addition to that, which I really wanted to just show you this because this takes a little while to load, is this neighborhood browser. So they're able to present a map here and then show the areas that are subject to perhaps some gentrification based on their gentrification score here. And we have to just wait for a second, but this actually area, if I click on, say, this particular area, I can get a score, which is a analytic or a metric that's produced by the Intelligentsia team, which is my capstone team, and also get other metrics that are based on data that they're pulling from other sources like Yelp, for instance, and Zillow, and other real estate sources. And you can even see that they map the average Z estimate for per square foot in this area, and reviews over time, Yelp reviews over time, that they look at this as one predictor for gentrification. The more reviews a neighborhood starts getting means that, you know, more cafes and restaurants are popping up. Taxi trips over time. So, and then they also give some preview of other properties that are nearby. So I'm showing you a project that was done by my team, but it's driven by Shiny and R, and they had their model built that kind of creates this these different metrics and this particular score and rating that signals gentrification happening in a certain area. And I just like to show this more just to kind of like inspire, not like to explain the whole, you know, they get like I think 30 minutes or so to give a whole presentation on this. So I'm not giving it justice in just like 4 or 5 minutes, but know that what you're learning here is something that then you'll be able to build on. And even though, you know, we're doing simple things, it's not that many more steps to get to something complex. It's just kind of putting the pieces together. And R is a kind of like a funny, you know, language, because to some degree, you don't necessarily need to be a programmer to work in it. You need to know how to work with data, and you need to understand what the models do that you use to manipulate your data. But once you just have the basics, you can be pretty dangerous. And that's why we have lots of other classes that talk about the important things. What do the models actually do? How do we interpret the results of those models? And so on and so forth. So I hope you think that this is kind of cool, because I do. And in class, I'll show you another Shiny app that another capstone team developed that had to do with predicting your, you know, marathon. If you're running a marathon, New York City Marathon, what your average time would be. Running a marathon based on many different metrics, and provide you with a training plan for preparing for a marathon to increase or decrease your finish time. So, good. So I'm just gonna move on. I know there are questions about the application, and I can answer those, but it's not so simple in saying like, yes, it's a regression model. It's many different things that yielded those different metrics. Okay, so now we actually did see a data visualization. So that was a graph, and it was using something called Leaflet, which is just an easy way to. We have an R package for Leaflet, and it's a pretty easy way to draw maps and make them web-based. We're going to move on, though, to talk about some important things in our basic points about visualizations in general. This speaks to session 5. You have a whole class on this that I'll be teaching in Shanghai, and everything I'll be showing you will be very visual. Here, I'm just showing you some text just to kind of explain where we're going with the visualization, and but this is pretty much the tip of the iceberg, and there's so much that we'll be able to do, and R isn't the only tool we'll be using to create visualizations. So things like Tableau and Python are also powerful environments. ArcGIS. I mean, there's so many different ways that we can create graphs and cool visualizations that say something. So, and that's the first point. Our visualization should say something. So we may be using visualizations for exploratory data analysis, and that's fine. Usually there's 2 purposes. One is to explore your data, and the other one is to present your data. So you have to decide what you're doing. But if you are presenting your data with a visualization, you want to make sure that it's easily able to be interpreted. So that's important. But for purposes, I think, of the R class, like, we're really using visualization to explore our data. And you, in most cases, are going to produce like thousands, and maybe not thousands, you'll produce like a lot of plots just to kind of interpret or explore your data. And then the next part is really communicating your understanding. Okay, just checking in. Everybody can hear me? If I can get a yes, that would be great. Thank you, appreciate it. And this is the second point I made, that a visualization can be considered useful for both presentation and exploration of data. And a few things that we'll be doing, right? So if you want to look at how 2 variables are correlated, like, we could use a scatter plot, right, to show that, to show the relationship between X and Y, okay, in a 2-dimensional space. And there's many different packages that allow us to create scatter plots, or even, other more sophisticated visualizations. And these are listed here in bold. Most of the uglier the graph, the more likely it is from the graphics package. Okay, the better looking it is, the more likely it's from like ggplot2. So again, we're gonna look at the aesthetics of graphs in addition to the meaning of the output. So there's kind of have to look at visualizations in 2 ways, and that's why when we use it for exploration, you still need to know how to interpret what you see, but making it aesthetically pleasing and 100% interpretable to anybody who would be looking at it is not as important. If you use it for presentation, then it's much more important. I think, yeah, you could see how that's logical. There's like some details I just wanted to go over. Like, when we draw histograms, for instance, you want to determine where the breaks are that separate the bins and the total number of breaks. So histograms look like bar charts, but they're not bar charts. A histogram is doing what? That's a question for you. Measuring frequency, grouping. All right, so what's on the x-axis in a histogram? So you're mapping one variable, right, into bins, into groupings or ranges, and what are we measuring? The length of the bar. What does that measure? Okay, that measures frequency, and that could be frequency in terms of percentage, right, or in terms of a count. We could do both. Okay, good. And so sometimes people look at histograms and think they're bar charts. And I know that sounds silly, but because when we were writing our code, we write HIST, and we know we're creating a histogram. However, just to know that when some other people don't always know that a histogram is much different than a bar chart, right? where we're measuring quantity, okay, rather than frequency. And we usually are mapping more than one variable in a bar chart. Even if we're doing something like every bar is a year, or every bar might be a category, like ketchup, mustard, mayonnaise, those are categories. And how many we have in stock, okay, would be the length of the bar, the quantity. Keith also has a nice point as well. You can check out the text chat. Thank you. And then we have another one we're going to be creating, or that you've done before in session 5, is a box and whiskers plot. And I always like to remind people what this is, and a lot of people get it wrong. And I'll ask, and maybe some of you will still be a little confused by it, because it shows the median and the interquartile range and the range of the data as a whole. And know that when we start looking at them, how you use them, whether you use them as a way to explore and understand your data better, or if you're using them at all for presentation. And they tend to be for, a little bit difficult for people to read and understand, just like the histogram. So again, we're looking at graphs that are not necessarily meant to be, things that you're going to publish on your blog, but rather, or really, to communicate something. They're really to kind of explore a lot more. Okay, and as always, I have the solutions for our exercises today. You can find them here, and they're also the links are posted online. We will most likely just go through exercise 5. I always like to leave another exercise for you to work on your own, so you can feel free to do that, and you can check out the solution there as well. And at the end of our in-class session, I'll also provide you with some other resources as well. So why don't we move on to my R environment. So you can go ahead and open up those exercises, and I'm just going to move over to R. Okay. So just make sure that you have your session 5 PDF file open or printed out. Again, you can find that in the materials section of this GoToTraining. And I'm going to ask, if I'm going too fast or too slow, that you let me know. Most people, I think, say it's been good, but I always like to ask, because there's always a different group of people here. So, and it looks like we have 27 people here total, which is terrific. And we're going to be working with a data set called Movies 2014.csv. I actually have, you can go ahead and you can get the newest one if you want from this website, thenumbers.com. So if you feel like working with a newer one, that's great. And I'm in my R environment, and I just want to kind of explain a few things. One is that when you open up R, you might have to reset a lot of things, or it might be a little bit confusing, like why stuff is saved or not saved. And so one thing I just would like to encourage everybody to do is to actually create a project. And this will be really, really helpful at some point if you're working on, say, a Shiny app with your classmates, and you can all publish your work to GitHub and work on it together, and then have a nice process for checking in and out files. So you and your classmates can work on, the same code at different times and check it in or out, or and work on, maybe different models, or work with the data in different ways. So just to help organize your work, one thing you can do is create a project. And so I'm going to navigate over to the upper right-hand corner, and you see that I have a project called Practice Exercises in Progress. And so, but I also have another project here called Becoming Visual. So if I click on that, it's asking me first, do I want to switch my project and I'm going to and save my work? And I'll say yes. So in my projects, I always have the ability to save. So it will save kind of where I left off. It will save my data sets that I've actually imported. So I don't have to go through from the beginning and import, Winter Olympics for the 30th time, right? Or any of those, right? So I would have those data sets that I've been working with active for the most part. And I can also easily organize my work from one context to another. So I just showed you my project that was for connecting to audio. Okay, hopefully you can hear me. I got another message that my connection was lost. I apologize. Yep, you can hear me back. Thank you, Mark. Gosh, it's a little frustrating. So I left off by talking about projects and how you can create a project in R. And one of the I navigated from one project, which was the project that I used for kind of teaching these online meetings. And then I navigated to another project in R using my tab here. And these are all things I created that allow me to create a workspace, and separate out my work. And so this is like, for instance, this is like a script I've been working on using like this huge like taxi data set and creating some pretty interesting data visualizations based on it. And everything that I save and open all go to my working directory for my Becoming Visual. So, and I have a different working directory for this particular project than I do for, when I go to the practice exercises one. So how do you create a new project? You can just say new project, and you have a few options here. So you can navigate to start a new directory or go to an existing one. Now, I would recommend that, if you're working with that My Data folder that I asked you to create, like in session one, like you can just use that as your working directory. But if you check one, and then you can decide where you can browse to it, and you'll be able to go ahead and just create a simple project. And every time you exit that project, it will save, and you can come back to it. And you're not going to have to set your working directory every single time. You can set it once, and it's like part of your project. So I would encourage you, if you plan on doing more work in R, which you're at least going to have to do for the next 2 classes that you take here, or 3, I would say, that you set up some way to kind of organize your work. I don't talk about this in the beginning because there are things like working directory and your data and things like that haven't been introduced. And so this is the point where it's kind of like you had practice with lessons 1 through 6. Now it's time to start organizing your work. I'm looking at what you're saying, Keith. I'm sorry that I got distracted by what you're saying. I'm not. Oh, okay. So what I'm doing here in my data, right? So this data set is really huge. This taxi data, and I'm just trying to do a few simple graphs, and it's too big to plot. And so I wanted to subset it based on just a few parameters. And I was curious, like when, how many actually taxi trips had more 3 passengers, exactly 3 passengers, and traveled more 20 miles or more. So I wanted to say exact, because if I said greater than, or if I said less than or equal to, then I'd be getting so much more data. So the file is like almost 3 gigs, and it's crashing my machine. So, which brings me to the point that you kind of, when you're going over 2 gigs working with data in R, you're going to want to think of a better solution and make sure that the data isn't necessarily, that you're not running R in your based on your laptop. You're going to want to think of a better cloud-based solution. I could reduce the columns as well, Keith, but right now I'm like exploring my data. So what I want to do is just I have a certain goal for my book about the types of visualizations that I want for this. But yeah, this is and maybe we'll even do the taxi example in class. But I will ask you before you even start working with it you could import a data that's very large, but then immediately you want to subset it, so then you don't have to work with that very large data set that could possibly, every time you want to graph something, crash your computer, or just take a really, really long time. So I have some other code you can just check out if you want. I'm doing bike sharing data as well. So one of my projects that I'm working on is I'm doing 5 different ways to look at Manhattan, and I'm looking at some transportation, some review data like Yelp review data, some running data, and a few other data sets to kind of present 5 or 6 different views of Manhattan. So Keith, I could do a random sample, but I wanted to, when I'm doing visualizations, and so one thing I wanted to do was create a story. And so my story is going to be about crowded, being in a taxi cab with 3 people maybe, and maybe I'll do it by time of day too, and by neighborhood. So it really depends on what your objective is for your visualization. And that's why we start with kind of some of this beginning stuff with just plotting histograms and just understanding the shape of our data and what it looks like, how big it is, etc. And knowing, for instance, what the average number of passengers is, the max, the min, for instance, for the taxi data. But these are all great suggestions. I can use help in my project. I'm a little behind on it. Keith. All right. So for today, I want to, I mentioned creating your own project. And if you saw what I did as I was talking, I just navigated back to my other project, which immediately brought up what I'm working on, which is the session 5 in class exercise, and some code there. So make sure you have your PDF file open. And as always, I'm going to encourage you to go ahead and do questions 1 and 2 on your own. So it's 7:10. I want to give you about 10 minutes to do questions 1 and 2. And let me know when you're done with that, and then we'll review it. And if you're done with it and you're kind of idle, then move on to questions 3 and 4. And so the idea here is that I'm going to ask you to, import your data. Maybe you should even create a project in RStudio, since we talked about that. View the data, look at the column names. That's all simple stuff. You can do that in a second. And then I want you to create some scatter plots. And I want you to redo the scaling on the scatter plots. Okay, because you'll see some of what happens when you don't. And then go ahead and see if there's any kind of correlation between tickets sold and sales, and if that's expected. And then you could also add a regression line and modify your scatter plot with nice labels. So sometimes when Mitchell says, can we talk about scaled data first? Yeah, I mean, in this case, what I can do to talk about it, so I'm just going to make sure that I have my data. And if I decide that I want to plot, you can see on the right-hand side, and bring up a zoom window so you can see my plot. So if I'm plotting 2 variables here, on the y-axis I have tickets sold, and then on the x-axis I have gross. You could do this either way. What do you notice? The numbers are really too big to be fitting as labels on my axis. Now I can go ahead and try to figure out what those numbers are and actually write custom labels for this, which is completely possible. Or I could say that I'm looking at, at this data in terms of, tickets sold in, in millions. Okay, that might be a nice way to talk about it. So I have some way, some unit that makes sense rather than the absolute unit. Okay, and so that's why we want to work with scaling. And so as you go ahead and do that, you know, you may notice that it's looking a little bit better. But when we can scale, then we can get a little bit more detail on our plots and possibly a little bit more meaning. We could certainly use a log scale. And then we have to ask ourselves, like, how interpretable is a log scale to the outside world? Do we want to use log scale for just ourselves and we can use the log function, which we learned, right? So you can certainly use a log scale if you feel like that's going to be interpretable to you. So for me, this looks a little bit more interpretable. So why don't you go ahead? I hope, Mitchell, that was, but we always want to, I hope that was like adequate explanation, but we always want to think about what our scaling is and if it's readable. And that's why I kind of use this data just to kind of show the, how the scales look when you don't scale them or normalize them. They do this a lot with, like, say, population or, like, say, crime data. They would, you wouldn't necessarily get, if you're comparing crime in one city to the other, you wouldn't say, okay, in, Williamsburg, Virginia, there's, this year there was 900 crimes. You would say that there was X number of crimes per person, per unit of population, per every 100 people, or something like that. So there's lots of ways that we can look at our units, and that will then allow us to compare, say, Williamsburg, Virginia, to, say, New York City. I would say, like, per 100 people, how many crimes are there per every 100 people in New York City compared to Williamsburg, Virginia, and then we can compare things, apples to apples, because we're using it per 100 people rather than comparing it to, like, say, whole population. So when you're done with, I kind of modified questions 1 through 4. Why don't you go ahead and let me know in the text chat, and you can post your solution there too. And Salma, I see your comment. It's a private comment in the text chat, and we're not going to be using any of the movie titles right now. So if you don't, you could just ignore that, as long as you're able to access the data, like tickets sold and gross. So, Salma, I see your other question, and you said there's an extra row of headers. Did you import it with header equals true? So what's the first row of data look like? Just maybe you could just type in, like, a few of the. So your data should look like this. Selma, I have it up on my screen where you the first column name is rank, second one is movie, and then your data should start after that. You could also take the long way of importing the data set just to kind of like go from CSV like I'm doing here, then browse to it, select your movies, open, and then take a preview of it. First row is names, and see if you can see any other preview of it. And then later on, you can convert that to a data frame. It's a comment eliminated, and that might be just a way to try it. And then you can go ahead and take this and convert it to a data frame using the data.frame function. Okay, sure. Okay, it's 7:20, so I just want to see how everyone's doing with this. If you could let me know if you need more time, that would be great. You just let me know in the text chat. I'm going to give everybody until 7:25. Okay, so Okay, it's 7:25. Let's take the time to review some of these questions for this exercise. And so I'm not going to spend too much time on reviewing, importing the data, looking at the data. So you should have a good sense of what your data looks like. So here we're looking at, quite simply, 50 observations of 10 variables. Okay, so we have 10 columns and 50 rows. And you can see it's done a few things, what R does, that I always just like to point out. So if we look to the third column, anytime there's a space between a column name, it puts a period in, okay? And anytime a column name starts with a number, it will put an X in front of it, unless you use quotes to distinguish that. So this is, doing lots of things here. And then you get really long titles like tickets.sold.millions, which is just like really long. And so it's always helpful to kind of rename your columns if you can. If you have the time, it will just be easier later on to work with that. But that's just an aside. So we start by doing a scatter plot. And I realized I had these reversed. So of basically our tickets sold versus the gross sales. So we can run that, and more time, and we see that we get something that looks like this. This is what I demonstrated before. And so one solution to this, to make this a little bit more interpretable, could be using a log scale. Another solution could be changing the units. So we can say that we're looking for, tickets sold and gross in thousands. And so we could simply divide those two variables by 1,000. So we can plot our variable tickets sold and divide that by 1,000. So we're doing two things at once here. So we're plotting our X value and then our Y value. And when we did that, what did we see? Going back here, zoom in. I mean, it's a little bit more readable, but gosh, right? So I don't even have any kind of information about this, like no title. My axis labels now have like the my division posted in here in my axis labels. So it's looking pretty messy. And I still feel like not every tick is really labeled. I would like to get a little bit more detail. And so one way to do that is to use a higher number we can look at scaling this by millions. Okay, so we can totally do that by plotting. So we've created two other variables here, and we can simply do a few things. One is pass in those variables. So now we're not doing, we have a variable that we can actually reference. Okay, and at the same time, we can add other information like our title. And I saw some of these solutions, which was great, but some of you didn't include some other elements that are important to a graph. So why don't we just take a look at the one that's up here. I mentioned a few things. One, that our y-axis label wasn't very descriptive. Our x-axis label is not very descriptive. We have this kind of frame around this. Our tick marks, each one isn't labeled, so it's kind of like, why do we have them to begin with? We have no idea what the denomination is or what the unit is. So 5,000 what? And there's no title to tell me what I should be looking at. Again, we're doing this just to kind of explore our data, not necessarily to show this to anybody, but we really want to get this. We can even do better for ourselves here. I think you would agree. So why don't we go ahead and plot with a scale of in millions. Now it's getting a little bit better. Just zooming in. So when I zoom in, I can actually see every tick with a number next to it, which is great. And then I'm seeing that I have a Y label and also an X label. But I should probably say something like, gross dollars in millions or something, tickets sold in millions. So that would also be helpful. So we can just go ahead and modify that. So here I have tickets sold, and I can simply say in millions. And that's a parameter in just the regular old plot function called xlab. And I also have my Y label, or YLab, okay? And I decided not to actually put a frame around my plot. If you can see to the right-hand side, you only see the lines for the X and Y axes. If I get this to true, I get that box around it, which that box really adds no additional information. Just scrolling back, again, I'm using a function called plot. If you want to find out more about plot, !plot, we can learn more about that in the help section. And we can see this is very generic. Okay, the usage is passing in X and Y, right? But we do get some other things that we can do. We can describe the type of plot we want to do. We want to do points or lines or for both. We can do a plot and not plot anything. So there is and then there are some other parameters we can pass in, like main, which is our title. You see up here, I have our title, tickets and gross. You could also include a subtitle if you want. We see the xlab, the ylab labels. So we can have a little bit of control, okay, over what our plots look like. So why don't I go ahead and just like bring that plot up again, just so you can see it, and then we'll move on. Okay. So you can see it's just much clearer than the previous ones. You know that you can kind of go back here by pressing the back arrow in the plots frame and look at your previous plots. So you can see kind of where we started was here. And that just looks horrible. If you wanted to export a plot, you can just go ahead and save as an image or a PDF file as well. So that's just something to consider. I'll show you the code that you can actually export your files so they come in your file section related to your working directory. So why don't we go ahead and go back to the plots, and then go ahead and go back to the plots. Okay. Next, we will look to see what the correlation is. So, and that's just using the core function, and you can run that, and obviously it's going to be 1. There's a direct correlation, so this is no magic. I just wanted you to like try running that. And then the next question I said was like, how do we add a line to a scatter plot? And that's where we can use that type B parameter, okay, to add that regression line. And so you can go ahead and do that. Again, that's putting that parameter. We just have type B. Some of you might have used ggplot and other packages to create your visualizations, which I'm going to go over actually, but I really wanted to start at the basic so you can see how to create simple XY plots, okay? And that's what's so powerful about the plotting function. While it's simple and your graphs don't look fantastic, if you just want to pass in X and Y and compare the values, it's pretty easy to remember how to do that. And you don't have to import any other packages or require them, okay? So it just gives you that toolkit. And as you get better, you'll be able to do that more with some of the new packages that we'll introduce you to, like ggplot2. And I'll write that down because it's this is a very powerful graphic package. How many people have used ggplot2? Anyone? Some people have. Great. Yeah, because I saw in the answers, and I also in some of your homeworks, I saw people using it, which is fantastic. So in this section, I have some extras. So there's, I want to introduce you to 3 different packages today, just so you can see that there are a range of options available for you to create some visualizations. This is not the end-all be-all, but it's these are some pretty powerful ones. So one is called car, and if you do question mark car to learn more about it, and not car is plural, car is singular. So let's see if I have my car package installed. So this is a companion to applied regression, and I could learn more about it here. It's not that exciting, but it does have a nice function for plotting scatter plots and using something called scatter plot. And it allows you to create scatter plots with box plots. And it's a pretty simple usage in terms of the function. It's simply scatter plot. You never have to really think about it. And you just simply passing in your data. So your X and your Y, and know that you don't really have to do it in any particular order. So I have my scatter plot where I'm passing in my labels first, actually. And then adding a title there, changing my frame to false, and then passing in my 2 variables, X and Y. And so this is a special library that you would have to install, the companion to applied regression. But if you do that, so I'll require it and then I'll run it, I'll kind of show you what you kind of get. You get your regression line, you get your box plots, and you get your visualization that looks like a little bit better than what comes out of the box from the graphics package. Okay, and plus you get the box plots as well. And again, this line representing what? The median, not the mean. So, and you also have the same type of functionality to add your labels like you did before. I could be a little bit more descriptive here. And we don't want to just have titles that don't say anything. So we'd like to, say something like there's a direct relationship between, tickets sold and revenue or something like that. So that's one that I wanted to introduce you to. And another is a package called ggviz, and I'll just type this out so you can see. Yeah, I mean, Keith, you're really looking at the range, the min and max, and the main business value would possibly highlight, the outliers to the rest of the data, and also show you where that middle point is. Okay, and where the ranges are. And I find looking at a single box plot not as helpful as looking at that when I'm trying to compare different variables along the same set of data. Okay, they still tend to use box plots a lot for dashboards because they are very, very, very useful and very compact ways for you to see the midpoint of your data, the interquartile ranges, and then where kind of like 50% of the values lie, right? And also to show, like I said, the outliers as well. So this next package, like I mentioned, is called ggviz, and I don't know how many people have heard of this. So if I go to my packages, you'll need to install this as well. It only takes a few seconds, so if you have time, you can kind of do that now. And ggvis is interesting because it allows you to connect. Right here it says like connect a ggvis graphic to a Shiny app. You can actually incorporate Shiny into your visualizations here. You can create animated and slightly interactive visualizations. Not very interactive in my opinion. You need to have Shiny to make something very interactive. Like interactive, I mean like filtering or something like that. With ggvis, you get a lot of glitz, but not necessarily a lot of functionality yet. But working with that and Shiny is a very nice toolkit you can have for visualization. So I'll just create one. If you wanted to kind of copy what I have here, but just want to show you the syntax is a little bit different here, and that just takes a little like getting used to that. But you can see that it renders a graphic that then can be exported to that can be a vector graphic. And vector graphics are great because I can insert them into a web page and make them, really big or really small, and I don't lose resolution. Where you could probably easily see from the other plots that I plotted before that the resolution was very, very, it wasn't very good quality, even just in the small display. So here, the resolution is much improved with this new package, ggvis. Okay. I haven't changed my access titles or put a title or anything yet, but I just did want to show you that. So that's something for you to explore. Trying to turn you all into DataVis junkies before the DataVis class, and also understand, what it takes to just try out a new package. So you've learned the basics, right? You learned, you learn things from the graphics package, and you've learned the plot function, and now taking that to using car and the scatter plot function, just to kind of encourage you to experiment a little bit around visualization or anything, and then taking it to another level, which is this package called ggplot2, which is probably going to be the one that you're going to use the most in addition to plot, especially when you want to develop presentation level graphics. But ggvis might be one that you'll be doing as well. Okay, so a few things about ggplot2. You need to make sure that you install that. And again, you go to your packages and you say install, and you would type in, okay, ggplot2. And I have it installed already, so I'm not going to do that. And I know some of you have already created the plots for questions 1 through 4 in ggplot2, but just want to show folks how it works. So there's a base function called ggplot, okay? And the first parameter that you'd be putting in would be your data. So our data here, I just called it movies. And then you have some ways in which are called like these aesthetic parameters. So you have, this is always a little confusing to people. You have a set of other parameters like what your data is, like your labels, things like that. But you're going to be using something called AES for aesthetics, and that's where we pass in this case, our X and our Y. Now, notice I'm just using ggplot. I haven't told if I want a line plot, a line chart, a bar chart, a histogram, a box plot, a map, anything. But that's what we do in the next step. So we have this. So I passed in my 2 variables. And then I can use something called GOnPoint. Okay, and that is, I'm just going to erase that for a second. So when I'm working with this, I can use these are all the ones that are available out of ggplot. So that's why I really like using RStudio, because you can experiment with these different types of, you can do a jitter plot or a step plot. And some will work and some may not work, okay, based on your data. So we're gonna go back and use the points. And I'm going to go ahead and I'm on this line here, just run that. Oh, and look, it says cannot find function ggplot. Why is that? Anybody know why I'm getting this error? Okay, well, I haven't required my package. So basically, I haven't checked it here. Now it's checked. Okay. So now after we looked at that beautiful ggviz, we're going back to ggplot, which it's like, the quality looks pretty good, but it's not as crisp as you saw the ggviz one, especially when I just scaled it, right, with the resolution. Okay, so at this point, we're still looking at the same data. Now, I want to take it to another level where we're gonna be adding our labels. So we just do that with a plus sign, just like we added GOnPoint, which just told the function what type of chart we want. We're gonna add something called, we're gonna do concatenation here, just a plus sign, and then say labs, which means labels. And then we're gonna add all these labels. We can add a title, a subtitle, a caption. So a caption that will tell us like the data source. And then we can label our X and Y axes. So I'm gonna go ahead and show you that. And you can go ahead and do the same. In just a moment, my demo is okay. Here I am. Okay, so I'm able to specify the title, the subtitle. I was able to change the X and Y, and I actually could put this caption here. Data was from thenumbers.com. Okay, so these are things that you definitely want to do when you have your graph. And they're, you may think of them as extras, but they do add to, comprehension, understanding, and always documenting where your source comes from is important. And so you can easily do that in ggplot. And now you don't have to go take your plot and, put the caption in like Word or like try to write it somewhere else you can actually have it as part of your beautiful visualization. And then at the end of it, if you wanted to save your plot, you can use a function called ggsave. So, because you're like, I'm doing all this stuff in R, but I want to just like put the plot on my website or, you know, share it with somebody in a Word document and not have to create a markdown. And so you can actually use this function ggsave. And where do you think it's going to save it to? Working directory. Very good. Okay, so the power of the working directory. So we can run that, and it says it's saving my image. Now there's other like parameters you can put in here for ggsave, but I can go over here to my files, and I could sort by date modified, and I should see my plot PDF. I can click on that, and on my Mac it's opening preview, but now I can see my beautiful visualization that I created. Okay, so that's another way to kind of get your stuff out of R. You know, of course, in RStudio, you can always go to export here and say save as PDF or image or anything, but that's also another way to do that. One other thing I wanted to just show you about working with plots is that you can actually, and I think I saw one person use, I don't know if it was Mike, I think did, or Keith, you use GG themes. Now, you can actually create visualizations that have aesthetic features and properties of newspapers. Like, for instance, you can make your plots look like they came from the Wall Street Journal, or you can make your plots look like they've been published in The Economist, or you can also have your plots take on the aesthetic design of how Edward Tufte, who's considered the grandfather of information graphics, would design a plot based on your data. You're saying, wow, what is all this? Well, it's a way to really make your graphs look very aesthetically pleasing. And so why don't I demonstrate? So we have something called GG Themes, and that's a package that we can use. So you got to make sure that you install that, and then you, of course, require it. And I'm using my same ggplot function, and at the end, I kind of say theme 538. Or I could say something like theme economist. Theme, I can make my charts look like Excel. Please don't do that. or Stephen Few, who is also a leader in the design of information graphics. I could make my plots look like they are generated in Google Docs. And there's many, many others that are here. Wall Street Journal. Some of them could be deprecated, but you can try them out. And see. So I think I had one here. So I'm just going to say plus, I'll write it with you, GG themes. Excuse me, theme. And you can pick one like The Economist, and then we can run our code. Oops. So here here I am, and now I can have my graphs look like The Economist. So, and that's just adding that additional line of code right here. I'm sorry, my screen is just a little bit wonky today. So plus theme and economist here. Now, again, you could choose another one. I mentioned Edward Tufte, so you can say theme Tufte, which I always think is very cool that they have one. Actually, in the last session that I did, that was the third one of these, somebody said we should have a theme Sisolsky. But I haven't showed you my aesthetics yet, so I don't think I'm worthy of that. But here's our theme Tufte. And you can see how it's very minimalistic. So if you're familiar with his work, a lot of his recommendations for charts and graphs are to remove grid lines and your axis lines. And he designs a lot of his work for print. So you see it's like using a Times New Roman. So hopefully this is kind of interesting to you. I haven't gotten too much feedback in the chat, but I hope that you've been able to try some of this. I like to kind of just, I mentioned I was working with like some taxi data. I always just like to kind of, I'll run a little bit of this to show you some other examples. So right now I'm just plotting some data from this taxi, from 1 month of taxi data in New York City. And you'll notice that you won't see anything in the plots, and that's just because it's still churning on my computer. And so you can see I'm looking how many observations I'm looking at. So I'm looking over at 1 million observations of 19 variables. And so it takes a real long time for sometimes your plots to render in this when you have a lot of data. So thinking about how you kind of subset your data is going to be important. And so we can probably wait for a long time for this to show up. And I like to show that just to illustrate that sometimes it's very quick to create these visualizations, but you want to think about how much data that you have. And so using it to explore data is great, but keep in mind that you want to kind of keep it under like a gig or two for like just performance reasons, just in your desktop. So I just want to open it up and see if there's any questions. There's question 5 is left to do some other plots. So I know you had a lot of practice doing box plots and histograms, and that's why I like to use these sessions just to, show you a few other things that you might be interested in. So I hope that the review of, I'm reading some questions, the review of plots and then moving on to some other new packages would be so here, the syntax for labs. Sure, we can look at that. And you're talking about for ggplot 2. So let's move here. So here we have labs. And this is, again, you're appending. So I chose beforehand, how it goes is that I use my function ggplot. I pass in my data. The AES stands for our aesthetics, which is telling it like what columns we want to pass in here. And then we can specify the type of chart we want with another plus. And then with another plus, we specify that we want to add labels to our chart. So it's like you can kind of think of this as all the stuff that you want to keep adding to your chart. And we use title is one, and that's also the same as main, okay, in our regular plot, but it's called title here. We can do a subtitle. We could even do a caption, which will usually you're supposed to use that for the data source. And then I can also specify what I want my X label to be, and then my Y. So Maybe it would be helpful if I copied this and pasted it here. Any other questions? Well, I hope you got some practice tonight. What I'm going to do is just stop the recording and then just take some other questions.